So before we go on to discuss what are OS operations and so on and so forth, um, Python provides you with an inbuilt OS module. Last week, we saw what a module is. So Python presents us with an inbuilt OS module. Now, this inbuilt OS module allows you to do reads from files. That is, allows me to go and either write information or read information or append information or read binary or write binary. These are all things in which I can do with my Python. Please, can you hear me? Talking to
Yes, I can hear you.
So if I take, for example, read, what is read? Read allows me to open, read opens the file for reading only. The file must exist or an error occurs. The file points, the file pointer is at the start of the file. So over here, if I have a file that I want to read, I would use R so that I can read the information, that is, get the information that I want. If I use W, then I want to write the information. So over here, I have the code to help me write information to my file. Then we have append information. So it opens the file for appending. That is, new data is written at the end of the file. And if the file does not exist, it creates a new file. And then we have a binary read. A binary read opens the file for a reading in binary mode, used for non-text files such as images and executables. And over here too, I have a binary write. It helps me to write information to a file, and it also helps with the images and executables. Note that if I use write, it means that the file exists and it is overwritten. So all the data there will be removed so that the new data that I am using will replace the information that is already there. With that information, let's see some examples of this. Now, I am going to create a file over here. Okay. The file I'm going to put over here, I'm going to put in a passage. Any passage will do. Do I have a passage? Okay, I sent some try questions for my students who are doing advanced Java. So this is the try questions that they should go and try. I'm going to save this file. I'm going to save it on my desktop, and I'm going to give it the name example, and it is going to save as a .txt file. Okay. Then I'm going to open my PyCharm. So this is my PyCharm. And then inside my PyCharm, I'm going to write some code. So I'm going to create a new file. And then in this new file, I'm going to call my new file. What do I even call it? Let's say reading info. Okay. Or reading in. So I've created a new file. And then in this new file here, I have to write some Python code to go and then write information in my file. So I'll say with open, and here it presents me with what do I want to open. So you can see that the first thing I want is the file. So I want to open the file called example.txt. Now, if I leave it like this, right, it has to be in quotes. Yeah, so let me put it in quotes. .txt. And then I have to tell it that I am doing a read. And I'm reading it as a file. Perfect. Now I'll bring my colon and then I can type in what I want to do. I want the content of it to be equal to the file that I am reading dot read. So this code here is what is going to read the entire file. And remember, in Python, if I want to comment, I use the hash symbol. And over here, my R has to be in quotes. So I'll put R in quotes like this. Then over here, I'll say that what I'm trying to read should be printed on my page. So I'm printing the content. Perfect. So with this, it is going to open and save the information as a file. This word here is the word I am using. So it is saving it as file. So I'm taking the file and I'm reading the information that is in the file. Perfect. Perfect. So with this, I can run my application. And when I click on run, I have an error. I have an error because it is trying to locate the example.txt. And example.txt is not here. So I'm going to go and fetch example.txt. Then I'm going to move it all the way in here. Yes. So now example.txt is here. Good. So now if I run this again, I can see that it has found example.txt and it reads, explain the key concepts of unstructured. As you can see, when I open it here, this is what is there. So it is reading the information that is there. That is how I can go and take information from files and bring that information from a file into code. Please, are we okay? We can do this too. I can say that, okay, when I want to read it line by line, I can go with open. I want to open example.txt and I want to do a read. And I want to do the read and save it as a file. And then in here, I want to go for the content and it should be, or Yeah, I don't want to just go and pick the content. So I'm saying that, what do I do here? I'll say for line in file, and then in here I can say print um, uh, line dot strip, print, so that it can read as a file. But unfortunately for me, mine is already line by line. So what I will do is that I will mash up these things together, or okay, let me leave it like this and then run it in first. So if I run this, I have it showing here, and this is showing line by line already. It's already in the line, so it doesn't make any sense that I'm trying to show it line by line because it's already in there. But if you have a set of coding which you want to read line by line, you can do it like this and it will read line by line. So let's say you have a file that has a name of students and you want to populate the name of students, then you can use this to fetch all the students and display their names on your page, things like that. Let's see, right. If you want to do a write, what happens? So if I want to do a write, so let me go for another example. And I want to say write underscore info dot info. Now in here, I'm going to say with open. And then in here, I'm going to put in output dot txt. And then I'm going to have a comma here, and here would be a W as a file again. So that here I can say file dot write. And what do I want to write? I want to write, I am in class today. Exclamation that. Good. And now I have to tell the computer to write the lines, and it is writing the lines in line 1 slash and comma in line 2 slash n. Okay. So these things here are arrays, hence they are supposed to be square brackets so that I can point which line they are going into. Perfect. So if I click this, obviously I don't have output text, but if I remember correctly, what we read said that if we run it and it is not there, it will create it for us. So let's see if that's true. When I click here, you can see I have created a file called output text. And then if I open output text, I can see I am in class today. And you can see that if I want to create multiple lines, I can create one on each line by putting them in an array and writing the details over here. Now, your mind should go to the possibilities. What can I do? If I want to, if I have a list of people, what can I do with? I can go further and say that with, remember, Python is indented. So if I do the width here, it means that it is inside the other width. So I must do it at the same line as it so that it shows that it is another width on its own. So with open, and I want to do an output of txt, and I want to do a write as a file, Oh, sorry, there's no dot over here. As a file, what I want to do is I want to do a file dot write, file dot write, and then in here, I want to append this line. So I'm just writing the code that I want to append. Now, if I do it like this, what is going to happen is it is going to override what is there and put this information there. So if I click here, it's going to override it. So right now, when I go to txt, this I only see append line there. So the first piece of code did what I did initially. But the second piece of code, because it is also a write, it goes and cleans everything there and puts append line there. That is not what I want to do. I want to append it. That means that this W here has to change from W to A so that if I refresh my code, I would see that I am in class today. I have line one, I have line two, and the code I want to append is on this line. Do we understand, please? I have this picture. Or picture one, it looks like this. Now, the picture, I want to write code that would go and pick the content of the picture. Let's say I want to do AI to scan what kind of picture I'm using and all of those. So in here, I'm going to go and create a new file. I'm going to call image underscore info. Since today I'm going all info, let me go info again. And then in here, I'm going to write the following code. I'm going to say with open, and I'm opening an image. So I have one.jpg. And then I'll go comma and say I want to do a read binary. So RB. And I'm opening it as a file. And the file is the name I'm calling it. You can call it whatever name you choose. So the file becomes the variable holding the information. And I'm going to say binary data. This is also a variable. Should be equal to the file dot read. Are we okay? So if I run this, it runs and nothing happens because obviously I haven't told the computer to print the content of the file. So I didn't say print binary data like this. So that it shows me that this is how the picture looks like. This is the code for the picture. So that if I want to use the picture to then analyze and say, okay, this picture is of a scenery, this picture is of a human being, I'm going to use this code to discover what that picture is. So if I want to take binary data, some executable file, someone else's code, all of those things, I would use RB, which is read binary. Is that okay? Now let's look at the OS model. The OS model allows us to interact with our operating system. The OS model is not something in which you play around with, I must say, but it is something in which you, as cybersecurity students, have to understand. Because remember, the course is not just Python, but it is Python for cybersecurity, which means that we have to add some cybersecurity into what we are doing. So let me write the following code. Import OS. Now, import OS is going to bring in the module for OS. Remember, we said that the module is a set of code you write. So I can write a set of code and then I can refer to the set of code I have written from another location. So it means that there is a file called OS that has code in it that we are referring to in this page. And in that code, I can then go on to do certain things. Like I can say the current directory is equal to os dot get. And you can see that these are the options for me. I can go and get the current directory so that I can display the current directory I am in. Now, if I click on this button here, I can see that I am in users map of PyCharm projects, and the project I'm working on currently is PyCharm 3. So it is telling me the location of my file. I can even go further. I can even go further and say that files is equal to os dot list directory. And I want you to list my current directory. Note that I can specify the address of where I want you to list. So if I do that and I say print into bracket the files, this piece of code over here will tell me where I am and tell me that in the folder I am, these are the files that are there. Very interesting stuff. So if I have to know where my files are, where am I? Or I have to know this user, what files does he have? What can I do with the files he has? Then I can do this. If I am a very observant person, I can say that, or I can go and put, you can see that this information here is saved in in like an array because it saves all the information here in an array. So I can say that, oh, I know that this person is going to have, let's say, example txt this in his thing. So I can check the array to see if the file I'm looking for is there. So I can do something like this. I can say, okay, before you print something out, um, if um, this piece of code um, is in files, um, then um, print file located, file located. Then this goes away. So if I run this, it will say file located. So then I can start looking at how I can write simple snippets to go into someone's computer and then scan the computer's documents and locate the file I am looking for and let me know if the file is there. And if the file is there, then I can go on to say, oh, okay, if the file is there, then with open into brackets the file name, and I want to do a read as a file, go and collect the information in the file. So I'll say, for example, like how we did at the top, content of the file um, is equal to file dot read. Then I can say print content. Wonderful. So that if I click here, now it will tell me that the file is located and this is the content. So that I'll be clear, before I print this, I'll just say print this is the content. Then I'll run it so that I'll see file located. This is the content. Sir Mark, this is what is bringing in the exam. Sir Mark, I've just hacked Sir Mark. So careful placement of things really help in what you are doing. I can go even further and say that apart from you going and determining if a file is the files that are there, apart from you determining the files which are there, I can say, oh, when you go into that folder, go and then create a folder for me. So I want you to create a folder called new. So if I go and click on this, it will tell me the folders that are there, the files that are there. And over here, I'll see I have idea this, I have that, I have an END, and I have that. But now I can see that I've created a folder called new in the side over here. I can even go further to see if the file is at the location it is supposed to be. Do you understand? So I can ask if I go if I go to a particular location, in the OS, check if this path exists. And I'll put in example.txt. And here I can ask it so that it will print out file exists. Now, when I click here, I can see I have an error because I'm trying to create the new folder again, and the new folder is already there. So let me comment this out. And when I click here again, it tells me that the file exists. And if the file exists, then I can start doing different things with it. I can start creating files and creating folders and pushing things where I need to have them. I can create subfolders. I can create all of those things with that file. Is that okay? Another common module would be the sys. To import sys. And then in here, I want to print out my system version. And yes, I can do that. But sometimes you would want to know the version the person is using for documentation purposes. What version of computer is this person using? So if I run this code, it tells me the version of Windows that I am using, when I last did my operating system update, and all of that information. I want to know what platform the person is using. So SYST will allow me to know the platform the person is using. And as a cybersecurity expert, this information is pertinent to you. What folder did it come from? What version did it come from? What platform did it come from? So that if someone makes a change in the system and it comes and it says, it's not me, it's not me. You say, oh, it is you. This is your IP. This is your operating system. This is the version you are using. Heck, this is the platform you even sent the information on top. It was a Windows 32-bit. I can go and see what arguments you have. And it tells me where the originator is coming from. Another thing which is very important for you as a cybersecurity expert is logging. The word logging allows you to keep track of activities that go on in your computer. Your computer has a numerous activities. It has numerous activities. And these numerous activities, your ability to log them is very important. Logging them, just simply logging them. Sorry. So we need to learn how to log. And yes, there is a module for logging. So it is also import logging. And I can create a basic logging config. So I can say logging dot basic config, and then in here I can put in my file name. So my file name is going to be app equal to app.log. I can say the level is going to be logging dot debug. And I can say the format is going to be percentage sign into bracket as time in seconds minus percentage time into bracket level names minus percentage sign messages. And I'll put an S here. Over here, there's a comma here. That's why this is given. And here, the format doesn't need any. The programming languages are played in my head, so forgive me today. So this is what I have. So I've created a basic log. And what does this do? In here, I can say, oh, I am logging a debug message, and I want it to be, let's say, the bug message. Or I am logging, let's say, an info. So in here, I'll put in the info message. Or I am logging a warning or a critical error or an error itself. So I can log all of these informations in. So that if I run this code, log.app.log will be created for me. If I open app.log, oh, I have an error. Sorry. Let me check this. Let me see. No. Okay. So logging.basic.config. I want to create my file name, which will be this. I want to create the level, which will be logging.debug. I want to create a format, which will be single quote, this one, ask time, and then, yeah, and then I have percentage sign, level name, and then I have percentage sign message. Okay, so that is all in order now. Let me run it again and see. Perfect. So I have no mistakes now. So that over here, when I come and I run this, I can see the time I have my error. So it tells me the time, and it tells me the kind of error I am logging. Perfect. Now, the beauty of this comes in here, where I want to do an application which would combine everything. So let me say I'm doing a new Python file, and I'm going to say combine dot combine. And then in here, I'm going to import OS. I'm going to import logging. I'm also going to import sys. and I'll set up the login. Okay, so of course, setting up the login would be this. So I've set up my login. I don't want to rewrite that entire code again. But here, I'm going to call it file underscore ops dot login. And then here would be login. And here I'm not going to do debug, but I'll rather do info. And then over here, I have the time, the name, and then the message that I want to put in so that it gives. Now, in here, I'm going to create a function. Remember, if you want to create a function, we will say diff, and then we'll give the name of the function. The name of my function is process underscore files. And then in here, we'll put in the directory that we want to process the files for. And then in here, I'll put a quote over here. And I'll say try. And remember, the try always goes with the catch. And the reason we use a try catch block is because if there is a failure in my application, the try catch will not let my application crash, but rather it will keep track of the failure. So here I'm going to say if, and remember, we haven't closed the try, not os.path dot exists into bracket directory. So if we check and the thing does not exist, then we should put a logging error there and say that the directory doesn't exist. And then we return or leave the function. Great. Now, for file name in OS dot list directory, and then we will list the directory. Good. Now, here we are saying that list all the files that are in the directory if the directory exists. So in here, we are going to say the file path should be equal to the os.path.join directory dot file name. Interesting. Now, if the os.path dot is file path, then we can say that okay, it is not dot, it is comma. Because you are checking the directories with the file. Then we can say that content is equal to f dot read, and then we will say logging dot info should be that we have read the file, and the file we read is the file name comma, the size of the file is the length of the content of the file. In bytes. In bytes. So F. Let me make sure I'm doing the right thing. So here we have this, and then in here, sorry, we have to do with open into brackets, file path, comma, and then in here we'll put R here. Perfect. And then we'll read it as F, so that this F will take place of everything. Now, if there is an error, let's see over here too, they are telling us we have an error over here, an error here. This is supposed to go deep in here, that this error will go away. And then here we'll set this dot, open brackets here, F for formatting, a small F for formatting. And then we have, but this F, yeah, the location of the F is correct. So this covers this, comma this, comma this, comma that. There should be no more errors. And I think the errors is coming from the catch over here. So we will say exception if there is an exception. Then the exception as E should be logging dot error. And then in here, we'll put in the error message, error processing file. Then over here, we have this, we have that, and we say str to a bracket and put the error message itself here. Great. So now let's see where the errors are. When we are done, then we'll just run it. So here, I can just run the code by saying that process file, and then maybe here I'll put in data folder. Good. So here, let's check our errors, or let me check my errors. Over here, I'm supposed to have a code over here, so that this code starts here and closes here. This code is not there, so that that error goes away. And then in here, I have an error here. What error is that? Can you tell me? More actions. Over here. Except or final is expected. Except I've done the except or final, so I don't know why it's populating. And then here it says what? End statement expects key paths. Let me see. So here it is a line, here it is a line. This one starts with this line, ends here. This one starts with this line. This one starts with this line, ends here. Here with it ends here. This has read, and it ends here. Now I want to log what I have read, so I'll go and pick what the person in here. I'll pick this. I'll put this and get the length, and then this closes that. I don't know why there's an error. Or this is supposed to be this. I don't think so. This is not. Uh, this is not. What do you call that language, bro? JavaScript. So I don't have to use the Cartesian code. It has to be this. So I don't know why I'm getting that error. Let me see. Let me check and see why. And the except is there. It starts here and ends here. Or the except I have to start with a capital letter. Oh, I didn't spell it. I did. Except. And then over here, I have the word exception. Oh, interesting. I don't know why I'm getting an error. Oh, okay. So over here, I made a typo. So here it's supposed to be login. So capital L or login. Oh, okay. The exception, I didn't indent it well. So you can see that this one and this one are not in line. So because of that, that's why it didn't know that the exception was there. So now that I did that, it means that all the other errors are also gone away. So you can see even from me the indentation. And I understand it from my point of view. Most of the coding languages are the same base. So writing in Python, I am, it's not like the C-based languages in which subconsciously I'm just writing. With Python, I always have to keep on telling myself that um, I have to indent. I don't have to bring curly brackets. There's no curly brackets in Python, that kind of thing. So with time, I'll also get there. So now my code is perfect. Ideally, if I run my code, I don't have any folder called data underscore folder. So on the side here, there is nothing called data underscore folder. So I am hoping to get an error. So when I run this, I am hoping that after it runs, I get an error in my op file that the directory does not exist. It is not there. So obviously, I can't run something which is not there. It doesn't exist. So you can see that immediately I get an error message over here. And this is the beginnings of the error logging. Now, if I create the folder, so let's say over here, I create a directory and call it data underscore folder. Means that now when I go to my code and I run it, the error logs will not tell me that the file doesn't exist because the file exists. But there is nothing in the file. So for example, I can go and put example.txt in the file, right? So that when I run this, now I have a file in here. So when I run this, it will now see the file that is being run in there. Hmm? I can see the file that's being run there. So again, if I go to my file ops log, I can see that it saw that example.txt was there, and the file size of it is 517 bytes. So I can use this code to go through an entire file directly. Let's say you are working with a law firm and the other firm brings a huge dump of data. You can use this to just go through and know the file sizes of each. If there's a word you are looking for, you can use it to go through and read the words you are looking for and then keep the logs. If you are working on a system for an organization, you can use the logs to keep track of what people are doing. So that at the end of the day, when you come, you can know which files they went through, when they went there, how big was the file, how did the file change, is someone making changes, those kind of things. You can start to log them and see how they are working and how they are doing things in the organization. In the organization. Please, do you understand? Today's class was to learn about them, to learn about, as I said, per our schedule, we're supposed to learn about file and OS operations, and we will learn about them. When we arrive here next week, we will treat them further by seeing how we can use some AI or something or some real world scenarios to log into people's files and see what we can retrieve and see what we can do or see how we can manipulate data like that. I have put all the codes in a PDF so that I will send you the PDF so that you can try them on your own and you can see how they are done from your point of view. Are there any questions before we leave here today?
So I have a question. Good morning.
Yeah.
Please, I couldn't help but notice that anytime you open the Python file, you didn't open the directory folder. Like in the beginning, the first lesson we had, I was thinking anytime you open a file, you add a directory folder. Please, can we do without the directory folder anytime you open a file? Will it work or?
The directory folder is for you to organize your data. In my case, I don't really need to organize my data, hence I'm not creating a directory file. For example, I could have done, let's say, directory folder lesson 1, right? And then
Yes.
I'll put in here lesson 1 classes in which we did, okay? I'll put in the lesson 1 classes in which we did. You can do it like that. It's to your prerogative. You just have to know you can create folders. If I was doing a work or embodiment of work, I will have multiple folders. I'll have folders for my resources, folders for my files, folders to keep my uploads, folders for my document, folders for my code, folders for my modules, folders for my environmental variables. I have folders for various things, but in this case, I don't really require them, so I don't need to create the folder. Plus, you guys are, I am assuming you guys are old enough, so you know how to create a folder, how to create a project. So you can see that unlike the other class, I don't come and say, let's create a project. We don't always create a project because I'm assuming you know how to create a project. Are there any more questions? So I will be sending to your class group this file. You will see that it shows you how to create a file with the explanation, how to log a module, all of those things. It has all of them here. Everything in which we did today, I've broken them down with explanations for you to have as a PDF. So I'll be sending you the PDF in your class group with the video. So I'll also be sending you some questions for you to try your hands on so that you can start getting comfortable with the way questions will come in the exam. So try them in your own free time. If you want to show me, fine. If you don't want to show me too, that is fine. All right. If there are no more questions, again, thank you for showing up today. We'll meet again next week. Next week, do we have class or you guys are doing it?
So midterm is next 2 weeks. So this week we have a class. Midterm is the following week.
All right. Thank you very much. So see you next